Welcome, everyone. Thank you guys very much for joining us. I hope everyone is doing great out there and having a really relaxing and enjoyable time. We're here, myself, Scott Sugden. I've got a couple of friends with me from L-Acoustics today to talk about sound design solutions specifically for performing arts centers and theaters. To kick it off today, I've brought along Jesse Stevens, application engineer who is an expert in the field of sound design for theaters, performing arts centers, and all things in that umbrella. Jesse, welcome. Thanks for coming.
Hi, everyone. Thanks for being here. Thanks for everyone for joining us in these crazy times. And thank you, Scott. So yeah, we're going to talk about sound design solutions for performing arts centers. And in this case, we're speaking about installations specifically. Installations share some specific challenges and difficulties, which Soundvision really helps us sort of conquer. So let me go ahead and get some visuals going here.
And I also want to just introduce quick BJ Shaver, BJ Sales Business Development Manager for installation projects in US and Canada, the Americas. I totally mangled your title, BJ. I apologize. BJ's here from Memphis, Tennessee. Welcome, BJ. Oh, BJ's muted. So once again, BJ's a sales guy, not a sound engineer. So
thank you, Scott. Thank you, Jesse.
Yeah, no problem. BJ, welcome. Thanks for coming along. And then I just want to let everyone know we've got Q&A going live right now. I'm going to be tracking these questions, and I will be able to show you guys a few things. Ask Jesse a few things he can show you guys. We also have some members of our German application team on board with us. So if you want to ask questions in German, please go ahead and do that. We're also trying out a feature of Microsoft Teams, which is we are subtitling this presentation in 6 languages today. It's a beta feature, so please give us some feedback if it worked great. Please give us some feedback if it worked not great. And we'll do our best to help you guys out through this. Really the goal here for the next couple of weeks is to improve your skills so that when we all get back to doing shows, installations, and projects, we're ready to go and better than ever before. Jesse, let's talk about theaters. What can we talk about when we talk about sound design for theaters?
Okay, so the one thing about Soundvision that I love is it's incredibly detailed, right? And it allows us to put in all these elements that are really, really important in a installation that allows us to sort of put in all those architectural elements and all those details that really help us get to the bottom of how to find the best sound design solution for an installation. In this case, we have a theater here. It is a real theater. I'm not going to say which one because it's sort of in progress, but you see, we can get the CADs and the photos of a venue, and then we have these CAD drafters on staff. We have about 3 of them, I think, worldwide, that all they do is make these really great models. So we can get the CAD drawings and the pictures and create these really, maybe not photorealistic, but incredibly detailed models that sort of put in all the elements we really need to look at when we're doing an installation. The thing about installations, how Soundvision is so helpful, is installations have to be incredibly detailed for their sound system. It's not like they're doing a one-off or a rental situation where they can rent a bunch of gear and set it up on stage and get through a single night. These guys have to use the sound system day after day. So it has to be covering all of their needs. Every bit of the house needs to be covered. Any sort of scenario they might encounter sort of has to be dealt with up front, hopefully, so that they don't have to sort of rent additional stuff. So we want to make sure that we cover all the bases when we're doing an installation, and Soundvision and the specificity with Soundvision really help us get there. So I've got this great model back from our CAD drafters. The first thing I'm going to do is I can sort of tweak the model to sort of just look right. So in this case, you can see I've got the picture here, and I sort of started color matching the walls so that we have sort of the right creamish color, although I've made it a little gray for our purposes here. And even do fun things like I've made the listening planes red to sort of color the seat color here as well. And one thing we can do with Soundvision is if I can bring back my thing here, is we can sort of, if I go to the system and venue layout here, we can sort of color stuff, so, or make things transparent. So in this case, we'll look at the isometric of the venue here, and the walls are sort of opaque. So the first thing I can do is sort of go to the walls group here and look at the color of the disabled elements. And then I have this alpha slider, which allows me to sort of add transparency. So if I want to have a sense of the walls, but sort of be able to see through them as I'm orbiting around a sort of dense and complex model, adding a little transparency really helps. The other thing I'm going to point out just as a pro tip here is we have these great different views in Soundvision now. So we have this views window, and there's a couple that are already set up. There's one that's just the venue. One of them is system and venue, which is pretty handy. It lets us to each grab the system surfaces as well as add loudspeakers. And then my favorite, which is 2D source, which gives us a detailed view of each source as we're trying to optimize it. So these are keyboard shortcuts as well, Control 1 and Control 2 and Control 3, which allows me to sort of quickly go back and forth between the different views as I need it. So I'll be using that a lot. So just keep an eye on that stuff. So the first thing I start with a model for once we get the model and we're doing a design for a venue is the design brief. What are the design parameters for the project we're doing? So the first one I start with is what kind of content do they have, right? So in this case, this theater is doing a variety of content, as most of these performing arts centers do. First of all, it's an orchestral hall, so it needs to be able to handle orchestral music, finely detailed music, probably not a lot of low frequency contour, but maybe a little. But it also has to handle rock and roll. So occasionally, from time to time, a touring act is going to come in, a rock and roll touring act. So we need to have enough level and enough low frequency contour to handle something as big as rock and roll, and then also be as detailed as orchestral stuff. The other thing, they have some sort of dance and playback shows, so we need something to handle that. And occasionally they'll do just a talking heads or comedy event. So in that case, we sort of need to have a rider-friendly system, since it's a bit of a touring house. They do their own stuff as well as tours coming in. So they're looking for a rider-friendly and a left-right system, right? So that's important to know. So we're looking to do left-right as opposed to, say, LCR or something more. Maybe sometimes place will just do a mono cluster. So they're looking for a left-right system. The other thing is they want to have good low frequency without having ground subs. So from time to time, a show comes in, and they can't put anything on the stage, no extra dish ground subs. So they need to have enough low frequency content in the air to be able to handle all the content that comes through. So that's important to know as we're trying to figure out a system that'll work here. Another thing they say is they need to have full coverage, right? So because this is a sort of wraparound audience, well, first of all, there's a big orchestra, right? Big orchestra level. And then there's this big wraparound middle area, right? And these audience areas come right to the side. So that's going to be really important as we start to design things, is to figure out how to get coverage there, but also not kill these people with really loud sound from the main arrays. There's also going to be a sightline concern we have to keep track of here. So we want to keep real track of this design challenge all the way up towards the stage here. And then, of course, in the very back, we have this second balcony, which not only has, a big balcony, but also has these little areas to the left and right of the follow spot booth that have to be covered as well. So that's going to be a difficult design challenge to hit. How do we cover this area effectively? To that end, one of the things, the design briefs that the venue has given us, is that they want to be able to zone this balcony separately from everybody else, because sometimes they do events that's not being sold, right? There's not enough people. So we want to be able to turn that off for a variety of reasons. So that's actually a really interesting clue for us when we're trying to design, because if we can treat that area differently, we maybe don't have to hit all of that with our main array, which allows us to sort of shrink our array, which allows us a little bit more flexibility in sort of where to put things. So what do we got? Rider friendly, left, right. We want good subs in the air. They want to be able to zone off the balcony. There's one more difficulty here, which is that there is since this is an installation, it's a historic old building, as you can sort of see from the picture. It looks pretty old and detailed. Unfortunately, there's not a lot of flexibility as to where we can put loudspeakers in this venue. There is occasionally we might be able to drill a hole, but for the most part, we want to go where there is existing points or where they have points that they're really have some easy steel. So the first thing they're going to say is we have an exact place where the balcony fills need to go. Hopefully we can fit something there that will cover the balcony fully. So actually, we're going to start there with the design, because it's a design brief that we have to follow, right? Speakers have to go in this location and they have to cover this area. So we're going to sort of start there. So to that end, the first thing I'm going to do here is turn on, I have the ceiling or the roof muted here. But it's important, this is one of those ways that Soundvision can really help us out, is we have this very detailed roof, and our CAD draftsman experts can really put in all these details with the CAD and sort of figure out where we got to fit. Now, it's sort of hard to see where we got to go here. I could sort of point it out, but I'll show you an easier way to see it in just a second. But essentially, we want to go right here under this little soffit. So it's about halfway up the balcony, about where this line is. but the speakers have to fit right under here, maybe shoot under this extra little soffit, and then cover. Remember, we have the main balcony as well as these upper areas. So the first thing I'm going to do is drop a source there, but the quick way to do it, instead of trying to finagle it and the 3D scene into here, is I can switch over to my 2D source. I'm going to add a new source. I'm going to add, in this case, A10 focus. So this is A10 in a vertical scenario. And so one of the things I have here is this source cut view. It's really handy, the source cut view. You can do a lot of stuff. One of the things you can do is if you hover over the speaker, you can grab it and you can sort of drag it into place. And luckily, my little soffit that I need to fit in is already modeled into this source cut view. So I can sort of easily drop in an A10 speaker exactly where I need it to go. Great, so we have a balcony fill position. That's great. Let's see if we can tweak this little array to sort of cover as much as possible here. So right now this is 3 A10 focus. I'm going to go ahead and open up one wide. Maybe I'll do focus wide, right? So that way I've got a pretty good coverage of this main array, of this balcony fill array. Next thing I'm going to do is sort of hit the sight angle, right? So I want to pan it up just slightly so the on axis of my top box is just overshooting the back of the balcony. And I can set my auto solver's maximum to sort of hit there. Now what I can do is sort of drag in my reference point and my minimum coverage. So let's take a look at what we have here. We have the maximum coverage of our array overshooting the top of the balcony. We have our reference somewhere in the middle, and we have our minimum. I'm actually going to set it so that my coverage just hits 100%. Since I can't vary this curvature, I'm just going to set the minimum so that I know that I'm covering everything. But once I have 100% coverage, and let's say I like my SPL target as well, I can actually, even without using auto splay, I can still use the auto solvers. I can use auto filter. I'm going to set this to 1 box per channel. So I'm going to assume that I have a single LA4X for this array, each channel powering its own individual box, which allows us to take advantage of these auto solvers. So now that I have my 1 box per channel and I have my position and my SPL target, I can go ahead and just hit auto filter. And you see we've improved our target a little bit here, and we've improved our flatness at the same time. So that's a really quick and easy way to sort of drop in a source and look at the optimize it very quickly. So let's switch back to our 3D scene and see how that looks. In this case, I'm going to turn off the roof now that we have our position, just so we can see better, and I'll view top down. And I'm just going to do a quick mapping. And there we go. We're looking at 1 to 10K here. And we have more gain to go if we wanted some headroom, but we actually have a pretty good coverage there for the one. The problem is that this one array, as you can see, even at fully open at 110, isn't going to quite do it. If I were to maybe slide, let's say maybe I can get by with 2 arrays. So if I move this one over to one side of the house and maybe try and get this upper balcony area and this side, let me just move it to, that's not far enough. Let's do 28 feet. More or less on axis, maybe a little further with our space there. And I won't go revisit that just yet. I'm just trying to get the horizontal here, see if I have enough horizontal coverage with 2 arrays. So I just symmetried that array just to see if I tweak these, could I make 2 work? And it actually kind of looks like no. It looks like even if I have 2 arrays and I could get it to cover the very back of the balcony area here I'm trying to hit, I'm going to end up with a bit of a hole here in the middle. So I'm going to need to add a 3rd array. So real quick, I'm just going to flip back and just optimize these outer ones now that I'm here, right? So I'm over on the edge. I'm going to tweak this up a little bit to try and get to the back of the balcony. I'll reset my auto solver targets here. And I'll just go ahead and rerun my auto filter, give me optimal results for that position and that pan. If I go back to my 3D scene, I now have 2 symmetried, let's say optimized coverage. So that's actually pretty good, pretty even across front to back. Still need that center one. So real quick, I'm just going to go ahead and copy one of these and move it to the center. And then I can switch back and re-optimize this one. So I'll go ahead and pan it back down as we had it there, set the reference, go to my electronic settings, re-optimize my auto filter rather. And then let's flip back to our 3D scene, look at top down and give a mapping. Great, so we've got full coverage here of this area. I could further tweak, right? I could use the fins of the 3 arrays to sort of maybe steer off the wall of the outer ones and maybe sort of narrow up the center ones so we can reduce the comb filtering. But for now, I just want to sort of get coverage in there. I find that when you're doing a design, especially one that's very complex with many systems, it's sort of best to get a first pass of everything pretty good. And then it's really easy to go back once you have everything cleaned up and in groups to be able to tweak things to sort of optimize everything. And I don't want to lead you guys through the arduous process of tweaking that I often do and second guessing myself when doing a design. So just for now, I'm going to go ahead and unmap this. And I'm a clean working guy. I'm one of those garbage in, garbage out guys. So I love to make sure everything is named appropriately and in the proper groups. So I'm going to go ahead and do that now. A few seconds of tedium really helps in the long run. So I'm going to say balc delay fills, make a group. I'm going to drag these three in there, and then I'll rename them just so that I'm clean. So A10 house left, A10 house right, and A10 center. Great. So I have a group. Okay, so that's our balcony fills for now. We'll come back to that, of course. But let's look at some other systems. So now that we have our balcony system, the next thing we can do is sort of determine where our main systems go and then what their coverage needs to be. So since we have to have this balcony area, we're going to try and cover just up to and maybe overlapping the balcony coverage just a little bit. Now, in terms of speaker positions, remember we have a very ornate and historical theater here. We can't just go wherever we want. We sort of have to go where we'd like. Luckily, the theater understands this thing, and what they're going to do is bridge these points above the proscenium. There's maybe 4 or 6 points up here. They're going to bridge that whole thing with a single truss so that they can put lighting and sound on it. That being said, that's where we have to go with speakers. So that's an easy solve for us, and I put in the truss here in this black line here. One thing to note is that in our model, you see that we have most of the venue, but we didn't model absolutely everything. Number one, that's not really, it's going to give us a lot of time, extra time to sort of make that model, as well as put all that stuff in there, as well as calculation time will take a while if we have too many surfaces. So we didn't put in everything. We also didn't have the CADs for everything. For example, you'll see this proscenium here is sort of in a little bit and curved, and we only have this sort of outer box. So we have to take that into account as we're dropping in speakers, is that we don't have the full proscenium, we only have this sort of outline edge. So we're going to go ahead and keep that in account as we're dropping in speakers. But the first thing we'll do is we're going to drop in a speaker. In this case, I'm going to use our favorite, latest and greatest, the Kara 2, which has just been announced. It's fantastic loudspeaker, a lot of options that you can do with it. Since it's got the new, it's got the L-fin technology we've been using for a while, which has proven to be very useful. So we've got the speaker. Let's put it in the right position. I'm going to go ahead and keep it at center for now. I'm going to give it a little bit lower. We'll have to see how that does with our sight lines over on the side in a minute. But let's first drop in some Kara 2. Let's take a look at what we want to do for that. So we can set the sight angle, right? We guess it's sort of here for now on the cut view. But if I go to the 3D view, it's going to be easier to see how those two systems overlap. So as I change the sight angle of this Kara, you can see the top boxes here are just the beginning of the balcony. If I go 6 degrees up, it's starting to kiss the coverage of the balcony delays. If I go 1 more degree, it'll overlap just a little bit, but hopefully not too much. We don't want to introduce too much cone filtering there, yet we still want to have the SPL. Back to my optimizing. Here I have my minimum, my maximum coverage, and my reference coverage positions I can set. The other thing I'm going to notice here really right off the bat is this right here on the source cut view, this dashed line. So what that means is that in this area, at least some of the boxes of the array are going to be shadowed by architecture. In this case, we have a balcony overhang here, of course. It's a bit low of an opening. So there's going to need to be some additional coverage in here that we're not going to be able to get from the main system. So that just gives us a clue to where we're going to need to add a few fills. So I've got my 12 box Kara. I've set my max, my reference, my minimum. I feel like I've set my top angle pretty well. So we'll see how that goes. And I've got 12 boxes, and right now, horizontally, everything is wide open. Let me just go ahead and run the auto splay. It will give us a result here for optimal mechanical angles. I can show here a pretty good distribution of SPL, really good flatness of HF, really good mean HF contour. I also sort of set the default contour here, which is 1 dB for 10 meter. If I want to make that a bit more accurate, I can sort of set +2, -2 target here. And just, you know, if I change my mind about my SPL targets, it's really easy just to re-optimize and resplay with new targets. So let's say I like what I've got here. I could make a few adjustments if I'd like, but I say I've got a result that I think is pretty good. Next thing I'm going to do is just run my auto FIR here as well. So in this case, I'm running an LA12X. I'm running it at maximum density, which is 3 cara per pair of amp channels, so high-low. So a total of 6 cara per LA12X. So once I've got my density here, I can then run my auto filter, which will improve my flatness score, try to hit my target a little bit better, and give me a pretty good result. So let's go back to the 3D scene and see how that does. In this case, I'm just going to solo the cara and see how it does on its own. And I'm going to look from the top view here in a second. Great. So actually, it's pretty good. We have a bit of a hot spot going on down front. The rest of the audience looks fairly even. Looks like auto display and auto filter have done their job quite well. We also see it starting to fall off right here at the balcony, sort of where we want the coverage to pick up for the balcony delays. So I feel like we have a pretty good coverage of that main there. Now, do we have that? Let's just see, let's get it in its actual position and see how it does and maybe sort of re-optimize for anything that might need to happen. So I'm going to go ahead and put it in its X position off stage. In this case, I believe it's something like 24 feet. So yeah, that's, if we look at it from the front, it's going to be just a little, imagine we have a couple of feet of proscenium in there. This is sort of near the edge. That's pretty good. The only other problem is I haven't moved it forward enough yet, so it's not quite sitting on the truss. There's a couple of ways to do this. I can sort of just type in a value here in the X, Y, Z. If I'm looking top down as well, I can grab the speaker and sort of move it where it needs to go. So I'll sort of place it centered right on the truss. We've got 25 feet off center. That's pretty good. So right away we can tell that number one, we're going to hit these people in the near area of the main array, sort of this side area, pretty hard. So we want to try and keep an eye on that. We're also, remember, we're seating this all the way up front towards the stage. So we're going to need to find a way that we can place a fill to fill in this little coverage gap area right here. So we've got the array in place. Let's go ahead and map it in its position and see how we do here. So as suspected, everything looks pretty great still. However, number one, we're off center a little bit, so we might want to consider panning the array in some. The other thing is as we said, we're crushing this first seating area here. So what can we really do about that? Well, there's two options in our toolkit. The first one is I can, as I said, pan this in slightly. So if I go ahead and give this, let's say 7 degrees of inward pan, which will also help us get a bit of a stereo sweet spot in the center of the house, it'll also help keep some of the energy off the edge. But then again, this is still, if I click anywhere in this mapping, I can see that in the middle of the house here, that's 105.5 dB. Yet over here in the balcony, it's 112, right? So that's 7 dB louder right there. So that's probably not a good solution. So what can we do about that? Well, luckily, the Cara 2 has these L fins, as we mentioned, which allows us to do some mechanical steering. So that's pretty helpful. The first thing I'm going to do is let's imagine that we steer everything 90 degrees to house right? So we're opening up towards the center of the house and trying to steer off the wall a bit. So I can just go over to my mechanical loudspeaker data here in my mechanical settings and set all of them to 5535, which is 90 degrees to the left. It's going to tell me that it wants to redo the auto filter, which is true. It's correct. It's going to have to redo that. So now we've steered everything off. But now what I want to do is, since the top coverage is sort of shooting really far, maybe I don't need to have 90 degrees coverage up there. Maybe I can narrow that up to 70 for the first 3 boxes to help us get mechanically a little better downrange without having to use electronic optimization. So this is pretty good. I'm going to start with that. So 70 degrees for the top 3 boxes on the same pair of amp channels, and then everything else is 90 degrees open to the end of the house. Once I've done that, I've got the fins the correct place, I've got my array in the correct place. I'm just going to go ahead and rerun my auto solvers. And now let's do a mapping and see how well that does for us. So that's much better. It's still not perfect. And I actually would probably want to get a little bit more coverage up front. I think I could increase my minimum coverage target here a little bit, try to get a few more rows up front of coverage. Let me just do that very quickly so that we can see how quickly and easy that is to do with the auto solvers. So I'll just literally reduce my minimum target, bring it a little closer, and then rerun the auto display. Okay, and then I'm going to rerun my auto filter as well. Great. So now we got a couple spots since we went a little closer. It's getting a little hot down here. We maybe deal with something like that. We still have a pretty good flatness score. So if we go back and just map that one array again, just see what it looks like on its own. Pretty good. Now these people sitting so close might have to just deal with it being a little bit louder, say 3-4 dB louder up there than it is down on the ground. The other thing we could do is maybe move this array more inwards. Then again, we would have to cover more over here in the outside. So it's all sort of a trade-off, but we'll start with this for now to sort of move things along. The one thing I want to check before I go too much further is sight lines, right? Remember we said we have people sitting all the way up front and they have to see the stage and they don't want to be blocked by an array. And if I can sort of move my camera view of Soundvision very delicately to sort of sit right where the audience listening plane is, I can sort of get a sense of what it would feel like to sit there and how the view would be. And in this case, it actually looks pretty okay. It looks like with the array at that height and that curvature, I can see underneath things to the stage pretty easily. So it seems like we've hit that target pretty well. Great. So we have a main array. We have our balcony fills. And let me just quickly, while we're here, first thing I can do is I will make a symmetry of that Cara 2. And I'm going to rename it Cara 2 house right, Cara 2 house left. I'll make a group called mains. All right. So we have our mains and our balcony fill delays. The question is, how do we time align them? Well, with Soundvision, what's really handy is we can do a lot of this work that we would normally do on site ahead of time. One of those is timing systems together. So instead of having to get on site and play pink noise for a long time and take a couple measurements and figure out where the best place to delay your system is, Soundvision can sort of predict all that for you ahead of time. So quickly, I'm just going to switch over here to delay mode. And I'm going to mute everything except for one side of the Cara and one side of the balcony delay. So what you see is dots, right? So you see the blue dots, which here on the scale mean single source mode, meaning that we're getting one source here. The red dots mean the sources are unaligned. Now this is based on whatever window we have set in Soundvision. The default is what I think is a pretty good default, which is 6 dB and 10 milliseconds. So that means if it's red, it means it's getting both systems, probably within our 6 dB window, and outside of our time window. So we're getting both systems at pretty much good level, but outside of our time window. And if we click on any dot, we can see the data there. And you'll see now why I am so obsessive about naming our sources, because we say here the highest SPL is our A10 house left, right? That makes sense. It's one right in front of us. And it tells us the level that it arrives at, so 107 dB and 11.79 milliseconds. Now, then it says below that, sources unaligned, 6 dB and 10 milliseconds inside of our window. In this case, we get our Cara 2 house left. We get it at 101 dB instead of 107, so just under 6 dB down. At 102 milliseconds with a delta, so the offset of 90.66 milliseconds. So really quickly and easily, I can pick a dot, say in the very front of this coverage. That number of the delta is 90.74. So if I had 91 milliseconds of delay to this balcony fills group, now we have common sources mode. Now if I click the same dot from before, I say that I'm getting the A10 at 102 milliseconds, and then I'm getting the Cara at 102 milliseconds with an offset of half a millisecond. So that's pretty good, quick and easy way to align sources. So now I can switch back to normal mapping mode. And again, our dots turn into SPL dots here instead of timing dots. So now I've quickly added delays and I've quickly added mains. One thing I'll do before we open it up to some questions for a minute and we move on is I'm going to add blown subs. Remember, we need to add subs that are enough low frequency in the air without adding ground subs. So in this case, we have the Cara 2. Its companion sub is going to be the SB18. It's not going to be stacked. We are going to do 4 of them. We always start with a ratio of subs to mains to give us an achieved low frequency contour. Remember, in this case, we're trying to hit everything from classical to rock and roll. So we want to have a robust low frequency contour. So we want to try and stick to that ratio. In this case, it's a 3-to-1 ratio for closely coupled subs. So we're going to fly these subs on the outside of the Cara next to them, so closely coupled. And it's 3-to-1. So with 12 Cara, we're going to want 4 SB18. The quick way I can do this to place these together is I can go to my Cara and right click and say copy position, and then go to my sub and click paste position. And you'll see that that adds the sub at the exact same place as the Cara. which is a good starting point. But what we'll do is, first thing we're going to do is flatten out the sight angle. So it's a flat sub. We're going to flatten out the azimuth for now. So it's 0 degrees azimuth, 0 degrees sight angle. And then I just move it off stage a little bit here. So I'll go 27, 28 feet. So now we have subs closely aligned to Cara. I can also take one of these subs and make it cardioid for an additional directivity. And now we're starting to see the beginnings of a system. I can also obviously symmetry my SB18s here. And of course, if you're me, you're going to instantly name them. Totally worth the 10 seconds it takes to do. And now we're looking like we have a good bit of a starting of a sound system. We have mains, we have flown subs, and we have balcony delays. We're still going to address under balcony, that shadow zone we saw before. We're still going to address this front area. We're going to need to get some front fills and mirror fills in here. And we're still going to need to address these corner trouble areas for these cheap seats right close to the stage but behind the arrays here. So yeah, before we get into the rest of that, I think it might be a good time to open up if there's any questions that have come up. Any questions or comments?
Yeah, Jesse, can you hear me?
Yes. Hi, Scott.
Excellent. Hey, buddy. Great job so far. I'm like overly impressed at your workflow, and especially the logic of maybe thinking a little differently. It reminds me a lot of mixing a band, and everyone always starts with the kick drum. You know, and maybe sometimes you should think about starting with the lead vocal or the guitar. Just, you know, the challenging parts of the design, not necessarily the simpler parts. So it was really neat to see you start with the balcony delay system and deal with that challenge first and what you could do, and then how the main system will work together with that. I saw a few questions specifically about autofilter, and I thought one of the neat features of autofilter you could maybe demonstrate or show everyone was how autofilter can actually show, like, obviously different amounts of amplifier resource. In other words, you are showing the LA12X with 3 Cara per DSP amplifier set, and we got pretty good results with that. The question is, can we get better results, and can we do that to kind of create a bit of a cost benefit analysis? Do we get better results with 2 boxes or 1 box and switching different amplifier types? You know, is that something you do on a normal? Is that something you can kind of show us how you can choose different things and maybe copy an array and see how much better it is with one format or the other?
Yeah, that's definitely something we can look at, and that's definitely something we do oftentimes. So the Cara, as you said, can do 3 boxes per pair of amp channels, and that's very great. Usually we start there. However, it's really helpful and quick with autosolvers to be able to look at a different scenario with the same deployment and see if maybe increasing the amplifier count, maybe 2 boxes per channel, give us any better option. So let me just quickly do that, and then we can see if there's anything else to talk about before we move on. But here's a Cara, right? Let me open up my 2D source mode here. So here's our original one, right? We have the coverage, we have our SPL target, we have our frequency response window, and we've gotten the target percentage, our high frequency integrity percentage, which is how good the HF is and even it is, and then our flatness, so how flat the HF is across the venue, plus or minus. So I have our control one here. What I can really quickly do is just copy and paste this one, and I can just call it test. Now, let me switch over to electronic settings, and here's where I'm going to go, instead of an LA12X at 3 boxes per pair of channels, what if I go down to 2? It's going to tell me it's going to have to reset everything, which is true. Now, we're going to have to slightly change our physical deployment because we had 3 boxes in 70 and the rest in 90. In this case, I'm just going to make a 4th box in 70 so that we have the top 2 zones, so the top 4 boxes in 70 degrees and the rest in 90. So I can what I'll do is first physically optimize this. It's always our first step is to get the best mechanical result before we add any sort of electronic compensation on that. So I've done the init and optimize autosplay. Again, we have a couple of bits in the front that are getting a bit loud here. And then I can go through and with our new optimization settings, hit auto filter. So that gives us a different result. But now the really cool thing is I can switch back and forth between my test group and my Cara group and see how those scores compare. So on our normal one with 3 boxes per channel, I've got 92.4% of our target with an integrity of 91.1 and a flatness of 1.9. And our test guy, which I haven't looked at, so we'll see how well we do. Aha, better target. We've hit our target better. We were able to bring these front 2 guys down much closer to our SPL target. We have a better integrity score, and we actually have a slightly better flatness score. So yeah, it looks like 2 boxes definitely does better on these scores we've done. Whether it's worth the money is up to you. But another quick thing I can do to compare the two is if I'm in solo mode here and I'm going to map them individually. Let me first do our regular Cara 2, 3 boxes per channel. And then I could compare that to our test option with 2 boxes per channel. So it's actually a little bit better. It looks like a more even distribution. It looks like that having that 4th box at 70 really helps us get to the balcony in a more controlled way and improves our scores a bit. So this is a nice way that you can quickly sort of go back and forth between different options and see which one's the most optimal for your, like you said, the cost benefit analysis here.
Cool. One other question, I think, and then we can maybe think about moving on, and this might be our perfect segue, Jesse. Someone was asking if using delay mode, for instance, time aligning your balcony will actually change your mapping results. And I think I could answer that, or you can answer that. You could probably even show it. So to the guy or person who asked that question, when you delay sources in Soundvision, of course, we're properly timelining, and that will change the results of what you get in terms of, say, the comb filter between 2 similar sources. However, one thing to remember is that they're only perfectly time aligned in, I believe, 1 spot. So only in that 1 spot will there be a significant difference. Everywhere else, you're still incoherent, right? So it's not that big of a difference. And we can probably show that if we want and turn the delay on and off, Jesse. But I don't think it'll make a huge difference one way or the other in terms of the mapping results.
Yeah, so I'm going to take this 91 milliseconds here, and I'll take it out and put it to 0. And let's just throw a mapping up. And of course, you are going to see a bit of comb filtering here. Even though we're looking at 1 main source and 1 delay source at this time, it is going to show the comb filtering where they overlap a bit. And let's keep in mind that it's not just the high frequency, it's also the lower frequencies, which are going to be a bit longer and go a bit further, so they're going to interact at different parts in the frequency spectrum between the sources. However, so yeah, we see a little bit of that comb filtering behavior appear where these 2 sources sort of overlap at the very beginning of their coverage. Now, if I were to add that 91 milliseconds back of the balk delay group, it's going to recalculate. So we are going to see the comb filtering. It's going to be a different comb filtering based on the time. So as Scott said, we picked one particular point where these systems overlap to make that basically the exact timing. We know that if we go back in coverage or forward in coverage, meaning closer to the or farther away from the main systems in relation to the fill system, we're going to have a different time by a few milliseconds here and there. So that comb filtering will still exist. It will just sort of change. But I think the ultimate effect when you're on site, obviously, is that you're going to have a much more system.
Yeah, what you could actually do if we really wanted to amplify this, if you want to flip to like 500 hertz only, something crazy,
Sure.
And that's where you'll really obviously see the difference. So if you imagine having, 2 speakers both doing 500 hertz, if they're offset by a millisecond, it's a really obvious comb filter. If they're offset by 91, you effectively have 2 very distinct arrivals, and it's chaos. And that's one thing you can actually play with in Soundvision. You can use this tool to help understand how those comb filters interact, how time alignment becomes so critical and important, so on and so forth. So this would be, what do you got there? Perfectly aligned?
So 500, no time, right?
Yep.
And then I'll add our alignment here as well. So we can see it aligns much better where we picked their spot, or here's our spot here where it gets much more aligned at 500 hertz versus if we were unaligned. Yeah, more of a difference.
So those are the kind of things you guys can surely play with in Soundvision. Take a look and see if you notice those differences one way or the other. And those are some of the things we can do. I think, Jesse, you were going to move on next to doing things like the front fills, the under balconies, the over balconies. Is that correct?
Yeah, of course. So now the trick is going to be to get coverage. To continue on our design here is to get coverage to the rest of the places we need to get coverage in. Remember, they're going to come in every day and fire up the system and do whatever show they're doing. They're not going to be able to add or remove, or all these cables are run through the walls. Everything is installed, so it's not a system that we can make changes to. So we got to make sure we get coverage everywhere. Now I'm going to skip for now just these under balcony side bits. I think from looking at pictures and having been to this venue, this looks like it's under this balcony more than it really is. I think the coverage shows a little shadow from this near array, but the far array penetrates under there. So it might be one of those where we add fills to the sides, but we're going to not hit that for now. what we'll do is we're going to start with that shadow zone that we discovered earlier. And it's sort of hard to see in 3D, sort of with all these walls and stuff. I could go through and turn some surfaces off. And as a matter of fact, I'm going to go to the back of the room. I'll zoom in from the back here, and I'm just going to right click and hide this rear wall so I can see through here. And I'm actually going to pan to the side, and I'm going to hide some of these walls just so I can get a better view of what we're doing. So we're trying to get under the balcony here. We see from our impacts mode here where our coverage from our camera is starting to drop off. I could map it and see exactly where that coverage is dropping off in mapping mode. Remember, we're looking at 1 to 10K here, so we're looking at the intelligibility range. So right at the top of this raked part of this thing where it starts to flatten out, that's where I'm sort of going to want to fill. And it looks like we have this soffit right here at the very edge of the under balcony where we can sort of tuck in some stuff there. It's probably a good spot to try and put some under balconies. So the first one I'm going to do is I'm just going to add a new source. In this case, when it comes to under balconies, I'm a big fan of having directivity in the vertical plane. The one thing that's really difficult about doing under balcony fills is when you have say a coaxial box and it's putting energy everywhere, right? So like all over the ceiling as well. So I think it's really interesting, if it's possible, to try and get a product that has some sort of directivity on the coupling plane. So the A10, for example, that we use in the balcony fill is a great way to do that because it keeps some of that energy off the ceiling, has that laser-like coverage along the coupling plane. We're going to try and do something similar here in the under balcony. So instead of an X8, which is a fantastic box, which I've used in under balconies many times before, we're going to try something new. And if we can do it, we're going to try the Kiva 2. So I'm only going to use a 2-box array of Kiva 2. Of course, I'm looking at my under balcony. Where's my Kiva 2? Quickly switch over to my 2D source. You can say it was dropped in up here. But again, real quick, I can grab this in this source cut view, drag it into where I think it needs to be, and then I can sort of zoom in and finesse exactly where that needs to go. So let me put this one right there. I'll give it a little bit of vertical so that it's just overshooting the back. And again, I can use my auto solvers again, even though it's only 2 boxes, whether it's for auto filter or auto splay, but I can set my coverage targets in it, optimize. It's just going to give me one little angle of 5 degrees here. So I could always myself change it a few more if I wanted. I'd add a few more degrees here. Let's go to 7.5. And then let's take a look at the 3D scene. Get my view back here. And there we can see approaching in the distance is our little under balcony Kiva 2 array. And it actually looks like it tucks nicely in up under that soffit as we saw in the source cut view. Great, so I can take a look at this and let me just map this and see what I've got. Okay, so the first thing we can see is the Kiva 2 is very wide, right? It's 110 degrees wide. So we have a lot of horizontal coverage to work with here. But we got a pretty good penetration here to the back of the room. You know, we've got coverage right a little before the top of this curved area where it flattens out. I could finesse that a little bit with the mains and these fills, whether I want to trade one off more to the other or when I have more or less overlap. Let's just call that good for now. Like I said, I like to go back and it's easy to tweak all the systems when they're in there, right? So the first thing I'm going to do when I work out fills is the spacing of the fills. And the best way to do this with Soundvision is just to use the Symmetry, which allows us to sort of apply something to one speaker and have it be same in the symmetrical speaker. So I'm just going to move this thing off center by 2 feet, and I'm going to Symmetry along the green-blue plane. And I won't rename yet. I know breaking my rules, but I will make a group under balcony, and I'm going to drop these in here. So now what I can do is I can use these impact circles. Remember, if you guys have taken a Soundvision class, the impact circles here, if they're a filled circle, it means it's within 3 dB of the loudest moment in that element of the array. And if it's a hollow circle, it's within 6 dB. So the general rule of thumb is we're trying to, with fills, with the impacts, is trying to just touch the filled circles together. That way we get a nice even mono distribution of sound across without too much comb filtering, right? That's our general rule. So now what I'll do is drag out this spacing, and all I have to do is move one of the arrays, and the other one will move in its symmetrical way. Now, the other thing is that I like to do even numbers of fills for a couple reasons. Some people like to put a fill on center. That's totally fine. For me, as an application engineer, I'm always being conscious of what's the easiest and what fits cleanest and most cost effectively. And in this case, since we have 4 channel amplifiers, and we can fit up to 4 Kiva 2 per channel on an LA12X, This means that we could fit all 4 of these speakers on one single LA12X channel, as long as they got the same thing. So in this case, we're going to want to do outer and inner pairs of under balconies. That way we can have the outer ones can maybe have a different delay than the inner ones in relation to the mains. But also, yeah, so then it fits cleanly. So if I have, say, 8 groups of 2 boxes each of Kiva 2, I could fit all of those under balcony fills on one LA12X, which is pretty clean. I do the same thing with front fills and then X8s maybe. I will do, say, 6 or 8 X8s because that fits really cleanly on a single LA4X or an LA2XI. So I like to do even pairs. So we're going to start with 2. We're going to move them around off center until we get a good distribution of the 2. Now, since this is very close, I would have to go very far apart for these circles not to overlap a little bit. So I'm going to take a little bit of comb filtering just for the to try and get some even coverage. And I also don't want to have huge spaces between fills. If somebody's up close, if I can get a good view here, you don't want to, I mean, right now at 7-foot spacing, this is 14 feet between arrays. I don't want to have somebody too much in the middle here and feel like they're in limbo. So I'll use a little bit, take a little bit of comb filtering to get a little bit of coverage, a little bit of a trade-off. But say I like that spacing, it's then really easy for me to apply that spacing to the rest of the arrays really quick. So I can just take one array, copy and paste it. I'm at 7 feet, I need to add 14 feet to that, so that's 21 feet for that spacing, and then I can quickly symmetry to the other side. And then one last time I can copy and paste that and then end up with another 14 feet, 35 feet, and then symmetry that to the other side. Okay, so this is where my OCD kicks in. This is where I'm going to start labeling. I'm just going to do it quickly with 1s. This is 3. I'm going house left to house right. 2, 5, and 6. My OCD tells me to then rearrange these in proper numerical order. And now I have, if I could solo through. And I could just quickly say 1, 2, 3, 4, 5, and all the way over there is 6. So now we have 3 symmetrical pairs of under balcony fills, all spaced evenly and spaced on center. And I can quickly just map that and see how that coverage looks. It's going to take a little bit longer because there's more sources. And there we go. Pretty good even coverage. First thing I'll see right off the bat is, according to our scale, we're a little bit hotter here than we were in the orchestra. Remember, we were sort of in the yellow-orange zone of the orchestra, and here we're into the white. So that tells me, since I'm so close, I could probably turn these down a few dB. So I'm going to go -5 for now. So I can turn the whole group down. And remember, if I wanted to make a change, I could change the sight angle of the entire group up or down dB. I could move them forward or back a couple of inches or feet. So that gives me a pretty good SPL down there. It gives me a good sense of that. I can then turn on my mains and see how these are interacting with our mains, making sure our coverage is adequate. Sometimes what I'll do, though, is I'll just look at one at a time. I'll sort of ignore the comb filtering, sort of see how much the main covers, where the overlap is with the under balcony fills, and sort of make sure it's good that way. So it actually looks pretty good. I feel like I could come down another dB or 2 with these under balconies. It's a bit red under here versus being a bit orange in the rest of the orchestra. So I can maybe come down another dB, but that's actually a pretty good start. The other thing I would do here, if I'm really doing this for real, is I would maybe follow the curve of this curved under balcony. A lot of times you would sort of tuck these back so we're following the curve of this soffit here. And that would, of course, change your delay times as well. But again, we're sort of doing this for expediency here today. So the next thing we're going to do after we've got our positions and spot is we're going to do a little time. So let me go to a top view and I'll sort of pan down and see if we can look in here. Now it's a little hard to see just because these systems don't overlap too much, so which is good. It reduces our comb filtering, but we do want to turn on a Cara, and we do want to turn on our center under balcony here, and we're going to switch over to our timing mode again. So this is showing me that I don't have a lot of overlap. I don't see any red circles, which isn't quite right. I do know I have some. So just for the moment, I'm going to increase the curvature of this just so I can see a little bit of red. All I'm trying to do is get a reading here about these two systems and their arrival times relative to each other. So I'll click on a red circle. The highest SPL is number 3, my center under balcony, 11.64 milliseconds. And then unaligned below that, we have the Cara and house left. It's arriving to us with a delta of 71 milliseconds. So if I go ahead and add 71 milliseconds to these under balconies for delay, now all of a sudden my previously red circle turns yellow. I can click and make sure that we're getting both sources with a delta of 0.09 milliseconds. I think that's pretty close. And while I'm here, I'm just going to gain this down, additional dB. Why not? Okay, so now that's how we got time and positions on under balconies. So let's quickly look over what we got. We've got our mains, we've got our flown subs, we've got our over balconies. Remember, our first thing we had to figure out was where these go, how they cover. So we have those as well. I'm just going to go ahead and unmute everything so we can look at the impact coverage. So yeah, we've got our over balconies, we've got our under balconies, we've got our mains and our flown subs. So still left to address is going to be this front area here, front fills, and then of course our little corner area bit up here. Well, front fills are easy. I'm going to go ahead and just add a group, fills, and I'm going to add, in this case, my favorite, the coaxial X8, one of my favorite speakers in our line. I'm going to gain these down. It looks like it's giving me an overload warning. It looks like I've set my console output level here to 5. I can just turn that down to 4 for now so that we don't have anything overloading. I could also quickly just say find max gain, and it will give us the maximum console output level as per our settings in the group here. Okay, front fill. We want it horizontal. We want it on the stage, so I'm going to put it at a height of 0. Actually, it's going to be a height of 0.06 for like 6 inches off, just so it's sitting there. And we're going to want it on the edge of the stage, so I'll move it forward 4 feet. Right, so there's our front fill. So the one thing to remember about front fills, and I'll turn my audience level off here just for a second. Front fills, depending on their height, can be useful or not. So in this case, if our audience is sitting head height at stage level and the speaker is on top of the stage, that's going to be great. We're going to probably get maybe 2, maybe 3 rows of coverage out of that. So we can't really rely on our front fills to do any sort of meaningful mirror coverage. So if I need to hit these areas over here in the corners, I might need to consider an elevated fill. Sometimes I'll do a near fill, maybe like under this balcony, to sort of get over people's heads and hit these near areas, right? That being said, we still want to have front fills. I think for imaging for the first couple people, it's very weird to have the sound coming from directly overhead or far off to the side. So we want to somehow maintain imaging as well. Now, really quickly, like I said, I like my even amounts of fills. I'm going to go ahead and just throw 8 on here. And I think it's a spacing of 4 feet or so. So I'm just going to quickly make these. So that's going to be 4, 12, 20, and 28 feet off center. So we can get a good view here. So now we got four front fills. All that's left is to symmetry. So that guy. So if you know your if you get your spacing, or even if you don't get your spacing, you just want to play, but it's really easy just to throw down 4 front fills, symmetry them, and have these pairs. And then you can really easily tweak from there, right? Because you have these symmetrical pairs. So I'm just going to go ahead and name these again, how I do. Usually I would put speaker name as well. In this case, I'm just going to put numbers. Remember, always worth the time to make your work clean, especially when you're looking at timing. It's really important you get that big window of all the different arrivals. If you have many different arrivals, it's really difficult to keep them all straight if the sources are labeled YZ symmetry of X8 copy of 1. So really quickly, I've added in some front fills. I could do the same process here and do some timing, figure out how to time the front fills to the mains. In this case, I would solo the middle front fill here. I would maybe unmute this Cara here, and if I lifted the front fills up just slightly so they mapped better, I could get a quick time. Right, so I'll switch to timing mode now. My computer's being a little slow at the moment. So yeah, it looks like the Cara arrives 20 milliseconds, 19 milliseconds different from the front fills because they're so far away. So if I added, 18, let's say, on the front fills, that gives us a pretty good time for those. Now, again, I would do these in inner outer pairs because I'm going to have a very different delay time on my center front fills than I will on my outer front fills that are nearest my Cara. So if I were to mute this inner one and unmute the outer one, I'm still within my window, but then again, to be really clean, I might want to, see I'm within 5 milliseconds here, I might want to just stagger these delays so they are more even, exact as possible with the main systems. So that was quick and easy. We've got mains, we've got balcony delays, we've got under balcony delays, we've got front fills. Now let's address this area here. So we have this truss, we have this extra bit of truss hanging here. We can ostensibly think that we can tail down from this truss to sort of have an array that's going to hit here. There's a couple different options for this. It's really easy, as we showed you earlier with a copy and paste position function, to try different products in different locations. But it's just easiest to get one in there, and then you can say, okay, let me try a coaxial speaker here, or let me try a variable curvature product here. But this is a good pro tip I'll show you guys about how to intuitively move a source around. So that's a pretty weird position. I'm trying to get it right here. I'm trying to get it at this strange angle and the strange pan. How am I going to do this quickly and easily without typing in numbers blind? Well, first I'll add a source. In this case, I'm going to add my other favorite speaker, the X12. You see, as I added it, adds its center of the room here and at a certain height of 16.05, 16 feet 5 inches. One of the things about Soundvision I love is there's a lot of hidden Easter eggs. So one of the things is if I hover around with my pointer, if my pointer turns into a finger, that tells me that if I click there, there's going to be something that pops up that's helpful. For example, if I'm on my SPL scale over here on the left side of my screen, if I click over my SPL scale, it turns into a finger. If I click that, it brings me directly to the options tab where I can change my scale. Same thing here with the XYZ. If I hover over XYZ, I get a little finger, and you say it says display source position. This window here on the Y is my favorite window, I think, in Soundvision, because it gives us a top-down view of the speaker. We can zoom in, we can see all of our architecture here, we can even see the truss that we have, so we can know where something needs to go. And then I can grab the dot of this speaker and drag it around. So I'm going to drag it into the horizontal position over here. It looks a little low right now, so why don't I click the Z, and I get this Z side view as well. So I can now raise this guy up. I can angle him down. And then if I click back on my Y here, I have my azimuth, I can get the pan going. So, and now if I, even with these windows, I can open up my source cut view window. Profile cut view, rather. Nope, I'm looking for my source cut view, not my profile cut view. So now with both of these windows open, I can really intuitively, if I zoom in, work on my overall sight angle, work on my azimuth angle, and then work on my positional angle as well, whether it be upstage, downstage, stage left, stage right. I can grab my source cut view and go higher, get a little more angle. So these two windows open is a really handy way to be able to sort of intuitively place a source. I think this, you know, the under balcony one I showed earlier, those are really quick time-saving ways to get a speaker in a very specific spot with your amazing 3D model, and then be able to intuitively sort of move the source around to sort of get exactly what you need. So this may not be exactly what we need, but I feel like it's pretty close. Again, if I wanted to try a different product, it'd be just as easy as me sort of adding a new source. Let's say in this case, I wanted to try a X15 high Q for whatever reason. I can right-click my X12 copy position, right-click my X15, say paste position, and there I have my X15 now in exactly the same spot as the X12 does. So now I can even solo between them if I wanted to see which ones got better. Obviously, the X12 has a wider coverage pattern here, so that's going to be more appropriate than the X15. But it's a really quick and easy way in Soundvision to intuitively place the source, try different products that might work in that location, and then see how that fits in with the rest of your system. So from there, as you guessed it, I would symmetry, I would rename, I would make a group, and then I would go about to adding some time. And then once I have everything in place, that's when I'll sort of turn everything on in the system. I'll look at all the SPL. I'll sort of balance the SPL across the different systems between front fills and under balconies and mains. I'll find the maximum gain the system can achieve with the gain settings we've set, and I'll make sure everything's timed together. And then from there, maybe I'll go through and I'll finesse the coverage target. So maybe I want to have a little less coverage of my balcony fills, a little more from my mains, or vice versa. Maybe I want to finesse the coverage between the under balcony fills and the mains. Maybe it's the side fills and the mains. Maybe it's a timing or level issue. But again, once I have everything in there, and labeled in appropriate groups, it's really easy to go through and make small changes to really get that last 5% out of your design that you're trying to achieve. So that is a crash course in designing quickly a theater.
Hey, Jesse, that was actually incredible. I really was impressed by that. A couple of questions that have come up. Someone noticed that you used LA12X on the under balconies. Is there any reason you used LA12X, or could you use LA4X? Is there any performance difference between those two scenarios?
There may be a slight performance difference, but it's going to be at the very loudest levels and at the very most demanding content. For under balcony fills, the reason I picked X12 versus LA4X is because it's probably going to be more cost effective. Because if I can fit as many speakers as I can on a single amplifier, obviously that's going to bring the cost down. That being said, I don't want to put a bunch of speakers on the same amp channel that need different control from each other. So I would want to think really carefully about, maybe for under balconies, for example, I would have put the outer speakers on one amp channel together. Since it's a mono send, they're not trying to get stereo, all the same signal, as well as having the same delay, right? The outers and the inners being symmetry are going to have different delays based on their location to the mains. So I want to do that in outer inner pair. So yeah, for me, in this case, the choice was made mostly for amplifier density and for design reasons.
Cool. Okay. Yeah, that makes sense. So you had two Kiva 2 on each side. You put all 4 of those on one amp channel. The LA12X can do that. The other choice would have been 2 on LA4X channel and the other 2 on the other LA4X channel. So it's just maybe the rack only had 4 used to fit all the amplifiers, so on and so forth. That might be a choice or a reason.
Sure, or it's also the cost between two, say to do 6 groups of 2, you're going to need 2 LA4X, or you're going to need 1 LA12X. So maybe that cost difference between the 2 or the 1, or yeah, maybe it's a space issue, or maybe it's a heat issue in your room if you have a BTU limit. Yeah.
Cool, thank you, Jesse. Everyone, thank you guys very much for joining us. I hope this has been beneficial to you. Jesse, thank you so very much for an amazing presentation on how to design with Soundvision for performing arts centers. If you guys have additional questions, don't hesitate to reach out to us on social media. You know us on Facebook, on Instagram. Don't hesitate to reach out to us here in the chat room for a few more minutes. We will be back online tomorrow at the same time. I've got Josh Mikely, our House of Worship specialist, to talk about sound design for church. Please feel free to join us. And on Friday, myself, Tony Zabo, are going to be talking about festival sound design. Thank you guys very much. Please be safe, be healthy, and go out there and learn as much as you can. We'll see you soon. Thank you, guys.
Thanks, everyone. Thank you.
Thank you, guys.